Solving limits with algebra. Sometimes limits are not only a linear function, it could have a more rational functions or a little more complicated functions that are not easily solved by plugging in the number that you're approaching for in your limit and problem is solved. So in this case, we have an explanation through an example that will tell you how to solve the limits with algebra and when you need the algebra and specifically the simplifications of algebra in order to solve a limit. You have here a limit of this function x squared minus 25 over x minus 5 as x approaches to 5 in this case. Now plug in the 5, it will give you 0 over 0. 5 squared is 25, minus 25 is 0. 5 minus 5 is 0. So 0 over 0, we said it's undefined. You can't just walk away and say, oh, so you can't walk away and you say this limit is undefined or does not exist. Sometimes the limit exists, but you need to do the right work to be able to find the right answer for that limit. So we said we plug in the 5, 0 over 0, undefined. That means we want to go to plan B. What is plan B? Plan B happens by simplifying this function in a more simpler form using the skills we learned in algebra. So ignore the limit for now, like the limit is not here at all. You have a function that is x squared minus 25 over x minus 5. How to simplify that function? X squared minus 25 can be broken down into x minus 5 multiplied by x plus 5. If you do that, you will end up with x squared minus 25 as you learned in algebra. Why we did that? We are looking for opportunity of elimination. So we're trying to get rid of the denominator or maybe just make the formula more simple so that when we plug in the number we are approaching for, we are having an integral solution and being able to tell that this limit exists instead of having it as undefined. So whenever your limit is resulting 0 over 0, that means you want to look into a different solution. So let's step one step backward. Always when you have a limit, you start with compensation. It means whatever number you're approaching for. So you see the limit as x approaches to 5, go ahead and plug in the 5 because the solution could be as easy as that. But if you have 0 over 0, then that's where you want to use some of your algebraic skills and whatever skills you will learn as moving forward in order to solve that limit as easy as possible. So back to our progress, we are simplifying this rational function. We have a numerator and denominator of variables. So we've broken down the numerator. So we find an opportunity. X minus 5 is exactly as the denominator. So x minus 5 in the denominator can be eliminated with the x minus 5 with the numerator. So we ending up with, as a function that we're simplifying, x plus 5. Forget about the limit. Now you have x plus 5. Let's try the limit on that. The limit of x plus 5 as x approaches to 5, that's 5 plus 5 equal 10. So the limit exists as x approaches to 5, the limit equals 10. Okay, let's move to a different example. Let's say you have a limit of this gigantic function as x approaches to 0. Most of authors are proposing this solution for you. I'm not sure if that relates to what's being taught in algebra these days. I can't really help on that. But I know this solution is complicated even for a person holding a PhD as myself. That solution need a little closer look in order to identify what's going on. So I don't want you to go through that. Forget about this. I'm not convinced about this approach. Let's use my way, or maybe that's a big word. Let's use what is the easiest way that I know how to simplify that function. Obviously, you have a complicated function with a numerator, denominator. Plugging in the 0, that will give you 1 over 4 minus 1 over 4, that equals 0, over x equals 0. So 0 over 0 undefined. That means we want to use algebra to simplify that function. How to simplify that function in a better way than what he did here? By the way, what he did here, he multiplied numerator and denominator by 4 by x plus 4 over 4 by x plus 4. If you ask him why did you do that, then he will hit a wall and give you a weird explanation, but in reality that's the only function that help you to simplify that expression. But I can tell you in a more logic way what we're gonna do and why we're doing that. So you have 1 over x plus 4 minus 1 over 4. So look at this as a separated expression or a separated function. All of these over x. Our problem is here, how to simplify this. X is no problem probably. So what you do, remember in your high school mathematics, you simplify two rational functions with addition or subtraction mark between them. That's what you're gonna do here. The way I do it, I cross multiply both rational functions and divide them over the multiplication of the denominator here with the denominator here. So we can say 1 by 4, that's equal 4, minus 1 multiplied by x plus 4, that's minus, between parentheses, x plus 4, so that's minus x minus 4, over the result of the multiplication of the denominators in this case. So it is 4x plus 16. Now, all of that still divided by x. How to combine this x here? Both denominator here becomes one denominator. You keep the denominator the same. 4 minus, oh, by the way, 4, that's plus 4. Minus 4, those will go away. 4 minus 4 is 0. So you are left over with minus x over whatever we merge from those two denominator multiplication. That's 4x squared plus 16x. Now, let's keep minus x as it is over. Now we have x in both sides of the addition in here. Let's do one extra step to make our life easy. Let's get x out of that expression multiplied by 4x, because we took 1x from the x squared, so we are left over with 1x, plus, instead of 16x, we took x out of it, that's plus 16. Now we can do some elimination. X in the denominator with the x in the denominator, that results in 1. That equals minus 1 over 4x plus 16. So that's the simplified expression that we had from doing the little operation that we did up there. Now, what is the limit as x approaches to 0? Because we did that to find the limit as x approaches to 0 for that expression that we simplified. That's the minus 1 over 4x plus 16. That gives you minus 1. If you plug in the 0 instead of x, minus 1 over x, minus 1 over 4 multiplied by 0, that's 0, plus 16, that give you minus 1 over 16. That's exactly the result that the other author had following his way of simplification. If you think this way makes sense, please go ahead and use it. Feel free to use it. If you feel this way makes sense, go ahead and use it. I'm just giving you more tools and more ways to solve that. Whatever works for you, whatever makes sense, please go ahead and use.